Okay, this video is for section 4.6. On your worksheet 8, it's labeled the real zeros of a polynomial function. This is kind of the apex, the high point of what this course is about. Being able to solve a higher order function or polynomial function um, to get all of the intercepts, all of the solutions, all the zeros, whatever you want to call them, for that particular function. Now, this thing is divided up into four parts. And what I'm going to basically, each one of those parts has like 3 questions to it. What I'm going to do here is I'm going to basically take you through one question from each one of the parts and then explain what they're trying to get at with those. Some of those will have exact images or types of problems on the test just like them. So all you're going to need to be able to do is kind of just um, use what we talked about here to be able to repeat that on those problems that are on the test. Okay, so the first set of questions, 11, 12, and 13, asks, use the factor theorem to determine whether x minus c is a factor. Well, on the screen here, okay, what I'm going to do is I'm going to my camera's kind of crooked here. Let me clean that up real quick. Okay, so what I'm going to do, what they're talking about here is division. Okay, so we're trying to divide, and in this case, that would be synthetic division. Okay, so when we did synthetic division, this is problem number 13, and I want to take f of x equals x to the 6th minus 16x to the 4th plus x to the 2nd. And I want to see, can I divide that by x plus 4? So here's what the synthetic division looked like. We drew the box upside down. Here, let me try. No wonder I was having trouble centering that. Okay. There it is. Okay, so with this example then, the first thing I need to do is put that quotient, or that first part of that, the function, in the box, inside the box. Now remember, you don't carry the x's down, just the coefficients. And if a term in the sequence is missing, we need a placeholder. So I have 1 x to the 6th power. I have a 0 x to the 5th. I have a negative 16 x to the 4th. I have a 0 x to the 3rd. I have a 1 x to the 2nd, a 0 x, and then a 0 constant. Okay, so an x to the 6th polynomial should have 7 terms. Okay, one more than the degree, 7 terms, including the constant. Now, the divisor out here, x plus 4, again, I don't want x plus 4 out there. We said whatever number you see attached, take the opposite of that number, and that's what's going to go out in front. That becomes your divisor. And to complete the synthetic division, remember 2 steps. Take the first number, first of all, bring it down by adding 0 to it, and then we multiply and then add. Multiply, then add. Multiply, add, multiply, add. So multiply, add, multiply. Okay, so it looks like that. Okay, now here's the key. All you're doing is this is a yes or no question. Is it a factor? Well, the only way that it can be a x plus 4 can be a factor is if the remainder in this very last term, the remainder must be 0. And it's not, so we would say no, not a factor. Okay, so that will be part of the process will be when we put all this stuff together as well. But this is the first stage, being able to perform the synthetic division to see if a linear term is a factor in a higher order function. Okay, so 11, 12, and 13, synthetic division. Okay, on the next group of problems, okay, 14, 15, and 16, okay, tell, given a function, okay, tell if the function how many zeros it has, and then use Descartes' rule, how many of them are going to be positive, how many are going to be negative. Okay, so here is a function. It's a fifth degree function. It has 6 terms, including that negative one as a constant at the end. Okay, and to tell the maximum number of zeros, all you have to do is to determine the degree of the polynomial. The maximum number is always equal to the degree. Since this is a fifth degree polynomial, okay, there are a maximum of 5 zeros. Okay, now the one thing about zeros, okay, zeros can be positive, zeros can be negative, zeros can be real, or zeros can be imaginary. Okay, we don't know what kinds of zeros this function will have. They could all be they could all be real, or you could have combinations of real and complex. Okay, we'll talk more about that as we wrap this worksheet up. Okay, but they could be real, they could be complex. Okay, but again, the first thing is to determining the maximum number, and that's just the degree. The second thing is, of those, how many must be positive? So with that, again, look at the original function up there. Notice that that function starts with positive, and then you got a minus. What we're looking for as you go from left to right down the function, how many sign changes are there? So from positive to negative, that's 1 sign change. From negative to positive, that's 2. Positive to negative, that's 3. Negative to positive, that's 4. Positive to negative, that's 5. So 5 sign changes means that there is a maximum possible 5 positive zeros. Okay, so possible. Now, if I determine the maximum number of negatives, the first thing I need to do is I need to find a new function. I need to find f of negative x. So I'm going to take a negative x and I'm going to plug it in everywhere up here. That's negative x to the fifth, minus negative x to the fourth plus negative x to the third minus negative x to the second plus negative x and minus 1. My next step then is to go through and simplify. Now, you do not simplify negatives first, okay, or double signs first. Use the exponent to simplify. So if I have a negative x to the fifth power, okay, because this is odd, this will stay negative x to the fifth when you simplify. Negative x to the fourth, when you raise a negative to an even power, it turns positive. So this becomes minus x to the fourth. Negative x to the third, you get this, okay? Thanks, Ryan. Oh, there's a big German Shepherd out in front, that's why.
Yeah. It's not even, I don't think anybody's walking by either.
No.
Are you still recording?
I paused it.
Oh. I didn't know you could do that.
Yeah.
Yeah, he's a big ass dog.
I know. I would say kind of looked like Rogers, but somebody's probably hollering for him.
I want to go check it, but I don't know if he's gonna like it. I mean, it's a cop dog for a reason. He's probably friendly. It's just that little shit. I know they're pissed. Whoever's dog it is. He's a big dog though. He won't get hit. He's.
Yeah.
You can see him on like our dogs.
Yeah.
Our dogs, correct, dude. Anytime they get out, I'm afraid they're gonna get hit.
Okay, so then continuing down the line, the negative x squared turns positive, so you got minus x squared and a minus x and a minus 1. Okay, so now that I've changed the equation to f of negative x, now count the sign changes. Well, they're all negative, so there aren't any. So the maximum number of negative is 0. Now, how is that handy? Well, unless you're given what the zeros are, when you're trying to find them, when you're trying to test, if you've got a list of 24 numbers you're testing, if you know that you can throw out all of the negatives, it just cuts your testing in half. And it'll make the time to find the ones that do work much, much easier. Okay? So, even though I'm not going to have you do much with this, this is something that, it's kind of a important thing to look at. It'll help you in some of the other things you're going to be doing later on. Okay, so that is for 14, 15, and 16. I need to know what's the maximum number of zeros that it has, what are the maximum number of positives, zeros, and the maximum number of negative zeros. Okay, on 17 and 18, there's only 2 problems in this group. What I'm asking you to do here is to find a set of potential rational zeros. Okay, in other words, what are some numbers that are possible that could work? And they found a little process for this, which was kind of nice. So number 18 says f of x equals negative 6x to the third minus x to the second plus x plus 10. Okay, and then from there, they were able to decide that if I want to create possible rational or potential rational zeros, then you take the last number in the list, the constant, make sure it's the constant, put that number over your leading coefficient, the first number, and then break it up into all of its factors. The factors of 10 are 1, 2, 5, and 10. The factors of 6 are 1, 2, 3, and 6. Now, to complete this list, you take the factors of the numerator and the factors of the denominator and you put them together. You create all of your different rational zeros. Now, notice I didn't put a positive or a negative out in front. I'm going to do that now as I write these out. So here's what's going to happen. So if I take the first number, let's do it like this. If I take this first number and I put it over each one of the denominator values, then I get plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 3, plus or minus 1 over 6. Okay? Now, you go to the next one. Go to the 2. Now, each one of these can be simple, not each one, but a lot of these will be simplified when you write your final list. So, plus or minus 2 over 1, plus or minus 2 over 2, plus or minus 2 over 3, plus or minus 2 over 6, plus or minus 5 over 1, plus or minus 5 over 2, plus or minus 5 over 3, plus or minus 5 over 6, and then finally plus or minus 10 over 1, plus or minus 10 over 2, plus or minus 10 over 3, and plus or minus 10 over 6. Now, as I simplify those, I also have some repeats. Okay, so repeats you can throw out. And, final list then kind of looks like this. You got plus or minus 1, plus or minus 1/2, plus or minus 1/3, plus or minus 1 over 6, plus or minus 2. And then here's 2 over 2, which is 1 again, so I don't need that. Okay, plus or minus 2 over 3. 2 over 6 is 1/3, already got it. Plus or minus 5, plus or minus 5 over 2, plus or minus 5 over 3, plus or minus 5 over 6, plus or minus 10. 10 over 2 is 5. And then it looks like 10/3, because 10 over 6 is back to 5 over 3, already got it. So this is my final list of possibilities. Now, we're dealing with the original function up here was a third degree function, meaning it has a maximum of 3 possible rational zeros. They might all 3 be in this list, or maybe none of them are in this list. Okay, that's important because all I'm doing is I'm using this list, okay, as a means to narrow down possible solutions. What you would do then is you would take these numbers. Now, again, if you're using Descartes' rule of sign, you might be able to throw out positives or negatives depending upon what it looks like up there. But based on this, I can start plugging them in using synthetic division until I find one that works. And we'll show you that process here in just a minute. Okay, but that's how you find the list of possible rational zeros. You're going to do the same thing on number 17. Okay, on number 17. Okay. In the last group of problems, okay, actually, in the last group of problems, the directions are different, but the process is the same. Whether they call them solutions or whether they call them zeros, you're still finding the same thing. So, here's what I got. Question number 21. How do I find all the zeros for a function? Now, 20 can be done by factoring, just so you know. 13 or 19 is going to be a lot like 21. F of x equals x to the fourth minus x to the third minus 6x squared plus 4x plus 8. Okay, so again, all three of these can be done using the same method. So the first thing I want to do is I want to find my PRZ just like I got done doing. So in this case, again, you're going to take the number 8 over the number 1. There's your constant. There's your lead coefficient. The factors on top are 1, 2, 4, and 8. The factors on the bottom are just 1. And the reason this works nicely is because I have no fractions to worry about. So 1, 2, 4, plus or minus. And those are my possibilities. Now, what I'm going to do, there are 8 possible solutions there when you look at the pluses and the minuses. What I'm going to do is I'm going to use synthetic division to see which one works. Okay. And normally I have an answer key beside me, and so I don't have to waste a lot of time testing, but I don't this time, so I'm going to try to make an educated guess and see if I can make this work. So let's try the number 2. So bring down the 1, and then I multiply. Okay, good guess. Okay, so when I plugged in the 2, okay, then that gave me the following answer with a remainder of 0, so 2 is a factor, okay? And so that's one of my answers, okay? Now what I want to do now is I want to take that answer and I want to plug it in, and I want to do this again because this was a degree 4 polynomial. When I divided my first answer out, okay, when I divided my first answer out and got the 2, then that gave me an expression that okay, so here's where I'm at. Sorry, I'm having a problem with the video here, so I'm hoping that you guys didn't lose me in the process here. But in this exam, so I've taken the possible rational zeros excuse me, I factored out or divided out at 2. I got this expression with a 0 remainder. This was a 4th degree polynomial, okay? This is a 3rd degree, okay? So I want to continue this until I get down to a quadratic, okay? That's what's important here, okay? So I want to take this, I'm going to try a -2 this time. Okay, so that one also works. So I found 2 of my answers. I found 2 of my zeros, +2 and -2. Okay, but I also have been left with a quadratic. Okay, so this was x to the 4th. This is x to the 3rd. So guess what? This is x to the 2nd. So this gives 1x to the 2nd minus 1x minus 2 equals 0. Now, this is factorable. It breaks up into an x minus 2 and an x plus 1. And now I can set those equal to both to 0. And so x equals 2 and -1 are my final solution. So here's the thing. As I list out all of my zeros, all of them turned out to be real. I end up with -2, -1, +2, and then +2 again. So those are the 4 zeros that came from this. So that's a long process when it's a 4th degree. I tried not to leave you those with too many here, but when you have a 3rd degree, you only have to go through this PRZ process in synthetic once. Once you get to a quadratic, whether it's quadratic formula or whether it's factoring, it's a little bit easier to do. Okay, so and the last question, same thing. You're finding solutions. It's just not given in a function format. Okay, so on this one, you have number 23. You have 2x to the 3rd minus 11x squared plus 10x plus 8 equals 0. Again, do a PRZ. Okay, so I'm going to put 8 over 2 this time. So 1, 2, 4, and 8 on top. 1 and 2 on the bottom. So I get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 1/2. And that should be all. The rest of them are all duplicates. Okay, so that should be it. Okay, so testing these using synthetic division. Let's try -1. Okay, that one didn't work. Let's try Okay, it looks like this one isn't going to work either. Let's try the 1/2. I'm going to go with negative 1/2. Okay, so bring down the 2, multiply, you get a negative 1. This becomes negative 12. So 1/2 of 12 is positive 6, which is 16, and negative 8, there it is right there. Okay, so here's my first answer. Okay, and remember, since this first one was a cubic, then this is a quadratic. And a quadratic is what I wanted, so I can put it back into a quadratic form. Okay. And one other thing you could do that would be helpful is everything as a greatest common factor of 2. So divide out a 2. And it looks like this is factorable. It breaks up into an x minus 2 and an x minus 4. So I picked the wrong numbers up above there, but so take the negative 1/2, set this equal to 0, you get 2 is an answer, and 4 is an answer. Okay, so there are my 3 zeros for this particular solution, or my answers or solutions, I should say. Any one of those values would make that thing equal 0. Okay, so like I said, this is kind of the tough point of this entire unit. I understand if this is going to take a little bit more work. If you need some more examples, you can search out some stuff on YouTube that will show some examples for you on how to work. Just look up zeros of a polynomial function, and you might see some more things that would help you as you're trying to complete these. Okay. Otherwise, email me and I can do some more to help you as well. Okay. So, section 4.7 is the last of this unit, and then you can go ahead and start working on the test. Actually, you can start working on the test at any time, and then we'll wrap up section 7. It's kind of short, and then move on to the final chapter for this course. Okay. Thanks.